Okay, so today we're going to look at the sine law and what happens when we need to solve for an obtuse angle when we have to use the sine law. So I've set it up so that we can use both the sine law and the cosine law because I want to look at comparing them, and we're going to come up with some ideas. So what I'm looking at is I want to try the sine law. So I can use this and this, and I can use this and this. So I'm looking for sine of r. So I'm going to start over here with sine r, and I'm going to put that over side r, and I know p. So I'm going to say, well, this is sine p over side p. And then I can fill in the information. So I'm looking for sine x, and it's over 12.6. And I have sine of 30 degrees, and that's over 7.5. So I can isolate for x. And I can plug that into my calculator. I'm going to round to the nearest degree just for the time being. And when I put that in my calculator, I can do sine inverse bracket. I'm going to do 12.6 sine of 30, and I'm going to divide that by 7.5, and I'm going to close my bracket. And I'm going to round to 57. So I get approximately 57 degrees. I want to try the same thing with the cosine law. So I'm looking for this angle, and it's contained between this side and this side. So I'm going to look and say, well, I want to do cos r, but I don't have it. So I actually need all three sides. And I'm going to subtract the side opposite it. So I have p squared plus q squared minus r squared over 2pq. So I'm going to insert the values. So I have cos r. I'm actually going to change that to an x. And p would be 7.5 squared. Q would be 6.8 squared. And then I'm going to subtract 12.6. And I'm going to divide that by 2 times 7.5 times 6.8. And I have x is equal to cos inverse and I'm going to do the top, which is 7.5 squared plus 6.8 squared minus 12.6 squared, and that gives me minus 56.27. And on the bottom I'm going to get 2 times 7.5 times 6.8, and I get 102. And I want to do cos inverse of those. So I'm going to do cos inverse, and I'm going to do bracket. And I want to do minus 56.27. And I want to divide that by 102, and then I want to close my bracket. And again, I want to round. I get 123. So I'm solving for the same angle, and in one instance I get 123 for the value of angle r, which is x. And in the other case I got 57. So one thing we need to be aware of with the sine law is it lies. Doesn't always lie, but it does lie. If we look at the diagram, we can see that clearly this angle is obtuse. So I know that the cosine law gave me the right answer. I know that the sine law lied to me. But I can always figure out what that angle is. If I look at my diagram and I can clearly see that it needs to be obtuse, To get to 123, we say, but we want the obtuse angle. So I can do x is equal to 180 minus the 57 that I got, and I will get 123. So we just have to be careful with the sine law. It does lie to you. One important thing to note is that the largest angle is across from the largest side. Which also then means that the smallest angle is across from the smallest side. So let's explore this idea a little more that the sine law lies to me. So what I want us to do is we're going to take our calculator and we're going to sit here and evaluate each of the following. So I'm going to grab my calculator and I'm just going to plug in sine of 25. And I get 0.4226. Now I'm just going to round to 4 decimal places. In this case, I don't need every last one. And then I'm going to do sine of 30. And I get 0.5. And then I'm going to do sine of 57. And I get 0.83867. You can round that if you want to 87. I'm going to try sine 75. So I want to do sine of 75. And I get 0.9659. And I'm going to keep going. I'm going to do the last column now. Now I want to look at the values that are the same. So for example here, sine of 155, I got 0.4226. And sine of 25, I also got 0.4226. Same thing here with sine 30 and sine of 150. Same thing here with sine of 85, sine 95. And then sine 57 and sine of 123 gave me the same answers. So what do you notice about the angles whose sine values are equal? Hopefully you noticed that they add to 180 degrees. So the two angles add to 180 degrees. We can say They are supplementary angles. That means they add to 180. So of the angles above, only one does not have a match. What angle would have the same sine value as this angle? So if I look, the only one that didn't match up with anything was sine of 75. I don't have another answer that matches this one. So if I want to know the angle that's missing, I can say that x is equal to 180 minus 75. This one was acute. So the obtuse angle, because it lied to me, would be 105. So if I check, I can do sine of 105, and it equals approximately the same thing.